Thanks, Regina. Good morning, everybody. Welcome to, as Regina mentioned, the New England Chapters, APWA New England Chapter Connect series. This is our first session of 2025, so thanks for joining us. It is a rather intimate group today, so pleasure to have you all on board. Our topic today is Twin Track Your Facility Asset Management, and this presentation will highlight use cases where facility digital twins extended through Dawood's native Twin Track mobile application and integrated with Autodesk Tandem facility management software, reduce inspection time by 90%. Our presenters will discuss facility digital twin implementations, combining laser scanning, intelligent modeling, and asset element and IoT sensor data in tandem, easily accessible via Twin Track, resulting in energy cost savings. Just a couple of things before we get started. I'd like to offer special thanks to our APWA New England chapter sponsors. Without their support, we could not bring all the valuable programs and events to our members in the public works community. All chapter events are made possible because of generous sponsor support, and their continued investment in our chapter is very important. So thank you very much to our sponsors. We hope that you will find the New England Chapter Connect series worthwhile, informative, and a good way to stay connected. This is our first session of the spring 2025 series, as I mentioned. We do have a second upcoming session in April, and it's called Growing the Future, the Role of Data and Community in Urban Tree Management. That's going to be Thursday, April 24th, so we hope to see you there. If you miss a session or you would like to replay a session for your staff, all of the New England Chapter Connects webinars can be found on the New England Chapter website. Lastly, please visit newengland.apwa.org for more information on becoming an APWA member or upcoming New England Chapter Connect sessions or becoming an APWA sponsor. So now let's get to today's session by first introducing our panelists. First have Mark McGowan, PLS, is Dawood's Engineering's survey manager in Braintree, Mass, with 40 years of experience in municipal and surveying engineering projects across New England. He specializes in boundary surveys, right-of-way, utility location, and infrastructure projects, including roadway, bike path, and wastewater improvements. His team also led surveying and modeling for the Nantucket Terminal Optimization Project. Kevin Hanley, PLS, is Dawood's Engineering's senior professional land surveyor in Braintree, Mass, with over 53 years of experience managing surveys across New England and beyond. Licensed in Mass, Rhode Island, and New York, he advises on state highway, municipal, and military infrastructure projects. His expertise includes transportation and utility improvements using LiDAR, aerial surveying, laser scanning, and conventional methods. Simone Paspik, I don't know if I said that correctly, so I apologize, is Dawood's Engineering Solutions Technologist, has nearly 20 years of experience specializing in software development and digital twin technology. He leads the development of Twin Track by Dawood, integrating data with Autodesk Tandem to optimize facility management. Using AI and low-code platforms, he enhances workflows and improves decision-making for maintenance teams. So now I'll hand it over to Mark, and you can get us on with the session. Thanks a lot, guys.
Yes, good morning. I am Mark McGowan from Dawood, and first off, we would like to thank the New England chapter of the APWA for allowing us to make this presentation. And just a quick biography of Dawood Engineering. Dawood Engineering was founded in 1992 and spans over 30 years of growth and achievements. Dawood is a multidisciplinary professional consulting firm specializing in surveying and mapping, GIS services, BIM, VDC services, site and civil structural engineering, environmental services, geotechnical engineering, and transportation, wastewater, and construction management. Our New England office is located in Braintree, Mass, and Dawood Europe is located in Poland. And this presentation will highlight use cases where facility digital twin through Dawood's native Twin Track mobile application can reduce inspection time by 90%. In a variety of markets, including New England, wastewater facilities, and transportation infrastructure, TwinTrack allows owners, plant managers, and process engineers to seamlessly monitor assets and improve decision-making. TwinTrack also provides public works personnel with access to technical documentation, operational guides, warranty records of equipment using their mobile phone app. Elements are tagged with QR codes, enabling rapid information access and on-site inspections. This allows for data exchange between mobile app and the digital twin using the Tandem API, making it the single source of truth. On-site engineers access information on the go during daily inspections and send inspection data to the digital twin. This helps management to respond to events in real time and reduce incidents. Day-to-day facility users create and manage work orders remotely in the web portal and assign tasks to the field staff working through the mobile app. And learning objectives of this seminar, or this presentation, is to understand how integrating Tandem with mobile apps, building management systems and documentation solutions facilitate faculty management, or facility management, sorry, identify digital twins as a single source of truth for making rapid, data-driven decisions, and to promote the benefits of cloud-based solutions, increasing facility management efficiency, facilitating maintenance, and improving public works decision-making. Our methods of collecting data, and Dawood collects data using airborne LiDAR, mobile LiDAR, and laser scanning for public works projects such as sewer, water, roads, bridges, piers, parks, airports, dams, and municipal facilities, including wastewater treatment plants, pollution control facilities, pumping station, and towns and city halls. And now this is a rare occurrence where an individual with 47 years experience is introducing another surveyor with 53 years of experience. That's a total of 100 years experience. So I'm handing this off to Kevin Hanley.
Thanks, Mark. It's hard to realize that college graduation was 53 years ago. And in those few short years, I've seen a lot of technology introduced to surveying and mapping. I've even been involved in scribing of assessors maps long ago. But do you remember when CAD was introduced? We had the ability to draw lines between points. Remember when GPS was introduced? Huge, big receiver, long observation sessions. Computers back then, huge, big boxes taking up desktops. And now your handheld smartphone can do all of that. And the mobile solution is the key to our TwinTrack solution. So it all begins with points. Years ago, it was single points, drawing lines between them. Now it's millions of points that are collected with ease. With laser scanners and mobile LiDAR systems, we're collecting anywhere from 500,000 to 1 million points a second. It allows us to do fly-throughs, video through the point cloud, video through colorized point clouds, so you can essentially do desktop inspections. And the ability to do colorized point clouds, the bottom right, this was a quote unquote a simple survey. We needed to locate tracks and the bridge abutments remotely without going on the railroad. So the picture you see is a colorized point cloud. So we extracted the rails and the abutment, but once the client saw these images, he needed more information. So we went from a simple survey to a 3D drawing of the bridge and the abutments. And we provided clearances for the wires and the bridge to the rails. The image on the left is a 3D model, a Revit model of a supermarket in Poland. So it takes millions of points, colorize images, and create these 3D models. Excuse me. So how do you track assets and their maintenance? What's tracked from a public works perspective? In these 3 simple images that contain the point cloud and the imagery, there's a number of items that you probably track, maintain, and assess their quality throughout the course of each day. Signs, height of them, the location of them, reflective quality of them, detectable warning strips or detectable warning pads at pedestrian crossings. What condition are they in? Lights, lampposts, trees, signs. How do you track them? Even this morning, driving into the office, the first intersection I came to, I noticed that the traffic light pole had been replaced and was taller than the other traffic light poles. How is that managed? How is that tracked? How does one know within the Public Works Department when it was installed and the material, etc.? So we collect millions of points, but few are generally used to prepare plans that engineers and public works officials use throughout each day. They're usually project-specific plans that may be very detailed, as you can see with the image on the right, but on their own, these plans do not provide efficient management capabilities. So here we are with the technologies that are available today. We've gone from points to digital twins. We started with points and point codes, simple data about the point, the coordinates, the elevation, the description, and maybe even a reference number. Then we've gone to GIS, and then with scanning and LiDAR, we've jumped to the next phase of data gathering. We can do fly-throughs, 3D models, BIM models, and digital twins. And the digital twin is a holistic view of a facility. It provides value-added solutions, and most importantly, it's geospatially referenced data. It provides cutting-edge facility management capability using twin-track data management. So one of the projects that Shimon is going to concentrate on today is a typical municipal airport. And I'll hand it over to Shimon now to make his presentation on twin-track.
Thank you, Kevin. So today, let me explore a little bit of how digital twins are transforming facility management. So as Kevin mentioned, it all starts with collecting data. Once the data is collected and we've got a BIM model, we can then import this BIM model into Autodesk Tandem software, which behaves as a host for our digital twin. And let me tell you a little bit about what that digital twin really is. So it is a dynamic virtual representation of an asset, process, or system. It's not just a static model. It's constantly updated with real-time data. It's enabling you to monitor, analyze, and optimize your assets. And in facility management, digital twins provide centralized digital view of your facilities, allowing you to access critical information, streamline operations, and make data-driven decisions. They also integrate data from various sources, such as IoT sensors, inspections, work orders, and to give you a holistic view of your facility. And in this example, I'll show you how easy it is to manage your facility. We can filter out any of the elements of the building to easily remove any plantings in front of it, if we need to access like air conditioners or any fuse boxes on the walls, we can filter out ceilings, roofs to preview the beams or preview the systems inside of it, like plumbing or HVAC equipments. And we've got access to all the assets found in a facility. We also got access to all the spaces in our facility. So we can preview each of the rooms, each of the spaces. And by having this real-time connection by the IoT sensors, we got the access to a lot of measurements. So we've got sensors feeding data about the CO2 levels, count of the people in the room, humidity, pressure, and temperature data. And we can easily visualize these values as a heat maps in our facility. So if it is a bigger facility, we can easily preview it in a real time on our desktop in a virtual environment. This way we can analyze how the temperature is flowing through the rooms, how many people are in each of the rooms, and we can make data-driven decisions and optimization to reduce energy costs or optimize our facility for foot traffic, for example. And facility management comes with a unique set of challenges. For example, accessing accurate and up-to-date information about the assets can be time-consuming, especially when it is a large facility. And managing work orders often involves multiple stakeholders, which can lead to communication gaps or delays. And inspection, while critical for maintaining equipment, can be inefficient and prone to the errors when done manually. And here we can see how easy it is to filter out furniture assets in our facility. We can cluster the cabinets to easier count them or to access any information which is assigned against these elements. And the digital twin technology addresses these challenges by providing a centralized platform where all asset-related data is stored and visualized. This allows facility managers to access information quickly, streamline workflows, and ensure accountability across teams. And in this example, we are trying to access pumps which are found in a machine room. And we want to see the information which is assigned against the pump. So we can see by who it was installed. We can see the manufacturer, serial numbers, when the warranty expiring. We've got all the information about the upcoming inspections. And we've got details about the open work order. But also we've got all documentation linked to it. So we've got technical documents, operational guides, or a warranty card, which is really easy to retrieve by the facility management team. And if something is happening with the pump, they can easily preview the details. A part of the static data, which is assigned against the elements, we've got also access to the real-time data incoming from the IoT sensors. So we can preview, for example, the active power of the pump, the casing vibration, the flow rate, the temperature or pressure. This allows us to monitor the performance of our assets in real time. And in this presentation, I really want to focus on the three main use cases. So accessing asset information, managing work orders, and performing inspections. So this hopefully will demonstrate how digital twins can simplify and improve these processes. So on the left-hand side, we've got the digital twin in an Autodesk Tandem, and on the right-hand side, we've got the TwinTrack application, which is a native mobile application integrated with a digital twin model. So let's start off by accessing the asset information. So imagine you are a maintenance team member in a facility who needs to check details about the specific air conditioner unit in one of the rooms. By pressing a scan QR code in the app, we're getting access to the camera, and we can scan the QR code located on the asset. By that, we are pulling all the information which are found in a digital twin while being on site through our mobile phone. So we've got access to all the documentation, operational, technical guides. We've got access to all the information, which is also found in a digital twin, but also we've got access to inspections history. We can preview when was the inspection done, and we can also see the work orders. We can preview the history of the work orders, check the tasks, what was done with the tasks in the past, and we can see if there is an open work order assigned against the asset. And we can preview all this information through the mobile phone. I also want to show you that all this information which is available on a mobile phone, as I said, it is being streamlined from the digital twin, which behaves as a centralized repository for all this information. So when the facility management team wants to update any data in a digital twin, they can easily navigate to the same asset, which is located in the same room, but in a virtual replica. And they can update these details through digital twin interface. Once they do it, once they upload new technical documents or a new supplied warranty card, this information is accessible through the mobile application by the on-site staff. And now let's move into the work orders process. So let's imagine you are identifying an issue with a pump in the machine room, and the process is the same as for accessing asset information. So we scan the QR code located on the pump. It pulls up the information about the pump on a mobile phone, and we can create a work order. So let's say we identified increased vibration on the casing of our pump. So we can add a title, we can add the description of the work order to make it more informative. We can set the priority of the task, specify the task type that allows us to easier group the work orders together or search through them later on. And we can specify a due date for this work order. When it is submitted, we getting a trace of it in the application, but also the facility manager gets a notification with all the details we just supplied in a application. They can now log in to it and preview all the work orders for their facility. They can see the history of them, they can see the completed, active, on hold ones, and they can action on the ones pending to be assigned. So once they preview the details, they can allocate the task to on-site facility maintenance team or the third-party contractors. If they select the third-party contractor, we are limiting the access to the data for them. So we are only giving the contractors access to the work order details and the asset to which this work order is relating. This way, we can ensure the data security. The facility manager can also update the work order details and work order due date and assign the task. At this point, the contractor gets a notification that the new work order was assigned to them. But we can also preview in a digital twin that this information was assigned against the pump in a machine room. So we get all this information stored in our centralized repository in our model. So when the contractor goes into the application now and navigate to the assigned work order, he can preview the exact information just for this one asset and access any technical documentation if needed, or operational guides which are needed for him to perform the repair. And once the work is done, they just need to specify what kind of work was performed during the repair, and also add the completion statement. This allows to keep both requester of the work order and a facility manager up to date with all the information about what was done to one of our assets. And when the task is updated, they also get a notification allowing them to be kept in loop with all work progressing in their facility. And the information is also being updated in a digital twin, allowing them to trace any work performed on site. And this provides the holistic view of their facility, and it also gives them the chance to track recurring issues, identify patterns, or optimize maintenance strategies. And finally, let's move on to quick inspections, which can be streamlined using the digital twin technology. And inspections are a critical part of the facility management, allowing you to regularly check your equipment and identify potential issues early on. And to schedule an inspection, the person on site can navigate to inspections. They are able to preview the history of the previous one, and they can schedule a new one by supplementing a date for the inspection and adding any necessary comments. So for this example, it is just a regular checkup. Once they schedule the inspection, the details of it are also submitted against the element in a digital twin. So by searching the element through the serial number in this example, we can see that that the information about the upcoming inspection will appear against the asset. Once the inspection is scheduled, the maintenance, the facility management team can see the whole list of upcoming inspections for a year, for an upcoming month, or for a week. And once the inspection is due for the element, they can perform it. And they need to provide the inspection details, the work performed during the inspection, which is being also transferred to a digital twin for the facility manager to be kept in a loop. And they can schedule a new one if needed, or they can just navigate back to the home screen. And that allows to keep all the information in a digital twin, but it also speeds up the time needed for performing the inspections and the work orders. And as I said, everything is centralized in a digital twin. And the digital twin changes how we are managing our facilities. They help us with improving paper-based processes, data collection, by giving us this virtual repository to store all the static and dynamic data about our assets. And I want to give you two examples at the end, which quite often are brought up during our implementations. And one of them, we identified that over half of the repairs which are done to the assets in our facility are paid for when they should be done on a warranty. And the problem is with the documentation, because it's quite often lost. The warranty cards are lost, or they're placed in between multiple departments or multiple cloud-based solution drives, or are just a paper-based documents, and it's really hard to retrieve them. And by just assigning this warranty cards against the elements in our digital twin, we can easily just press on the element and retrieve the document when it's needed. And the second example is, for example, based on the airport, when there is a small renovation project, and we need to repaint just one wall of the corridor, it's usually really hard to identify what kind of paint, what shade of paint was used for it. And we are ending up with repainting a whole corridor or multiple rooms or levels in our facility. Instead of just repainting this one wall, saving us quite a lot of money on labor. And this information can be easily assigned against the wall element in our digital twin. And by having this information, we are saving costs in the long run. So thank you very much for your attention. And if you've got any questions about our solutions and about digital twins, I think we can move to this part now.
Does anyone have any questions for these gentlemen? We have a quiet group today. Is there anything?
Yeah,
Mark, go ahead.
anything else, Mark or Kevin, that you wanted to add in?
The main point is that the technologies are there and are being used to create maps and surveys. But those maps and surveys that have been created from laser scanners, mobile LiDAR systems, aerial LiDAR systems, have a wealth of information that can be mined to develop additional applications within a municipality. And the simple thing that Shimon mentioned, excuse me, the shade of paint on a wall, it translates into other aspects of daily public works life. Look at the assets that you see along your public ways. How are they managed? Down to maybe a bike rack. But within buildings, how do you manage the furniture, the desks, or the cabinets? In addition to the major functioning elements of buildings, the HVAC system, plumbing. So it's the technology, and in many cases, the data is there. It's a matter of growing the information base that you can derive from existing data.
Fantastic. Thank you very much. Appreciate all the information. I look forward to the way that these digital twin models grow over time. It's really interesting to see what that data can actually produce from a building management perspective. So last call for questions in the chat, or unmute yourself and shout out if you have something on your mind.
Just a few plugs for our audience. I just put a link into the chat box for evaluation. If you can just give us a minute or two and let us know how we did today and what you'd like to see in the future, we would really appreciate that. And also, I'm going to put the April 24th Chapter Connects registration in the box as well. So we'd love to have all of you there. Okay. Thank you so much, gentlemen. We really appreciate it. Just to know that all the we did record today, and we will have this video available early next week up on the T2 YouTube channel, and we'll also have it on the New England APWA website. Okay.
Great.
Thank you.
Thank you, everybody, for coming, and thanks to Dawood for doing your presentation. Nice and short and sweet today.
Thank
Take
you.
care.
Bye-bye.
Thank you for having
Bye.
us.
Thank you.